Hi, I'm Ray Ciramelli. I'm one of the Master IPC trainers here at STI Electronics. Today, we'll be looking at Hot Tips number 6, terminal crimps with ring-type terminals. This type of terminal is typically used as an attachment point to a terminal block with a threaded fastener, also known as a screw. There are 3 steps that need to be followed to achieve success when crimping terminals. Let's discuss each one of these steps. Step number 1 is ensuring you have a CMA match between the terminal and the wire. In many cases, this is called out on your engineering documentation or your work instructions. If the information isn't available, you may have to research it and find it yourself. We are going to demonstrate how to ensure you have a CMA match just in case the information isn't available to you. The first thing we'll do is look at our drawings. In this case, we want to look at the 4 ring terminals up at the top of the drawing here. To get more information on them, we'll see the item number. In this case, it's item number 5. Once we've determined it's item number 5, we'll look on the parts list and identify the correct part number. In this case, we see it as an amp 36149 part. Now that we know the part number, we can look up the data sheet for this part. When we look up the data sheet, there's a section that gives us the CMA range. In this case, 509 to 3260. Now we go back to our original drawing to identify what type of wire is being used for this terminal. The wire part number is 1. So now we go back to the parts list and look up item 1. In this case, it tells us that it is a 22 AWG wire. Now we need to find out what the CMA is of a 22 gauge wire. There are many references and tables available on the internet. In this case, we found one. We look at 22 gauge, and then we see that the CMA, the circular mill area, is 642.4. This falls nicely within the terminal CMA range of 509 to 3260. Now that we know both the terminal and the wire have a CMA match, it's time to move on to step 2, tooling. This terminal is pretty common, so it's easy to find different tooling that's available to ensure we have a proper crimp. In this case, we found a match with a WT145C crimp tool. Now we've ensured we have a CMA match and we have the correct crimp tool, so now it's time for step 3, which is follow the instructions. The terminal data sheet includes all dimensional criteria for the terminal. But we don't want to have to break out our calculators right now. Let's just take a look at the terminal and see what it's made of. As we can see in this image, there's an insulator over the actual metallic portion of the terminal. The metallic portion is used to crimp onto the wire to ensure both a mechanical and electrical connection. The insulator gets crimped down over the terminal so that there's no possibility of shorting, and also a portion of that insulator holds the insulation of the wire in place, which helps to reduce stress on the termination point of the wire. Here's a view of a wire stripped to the appropriate length to fit this terminal. And this next image shows the wire inserted into the terminal. So now let's take a look at the actual crimping process. Before we get started into the process, we need to issue a strict warning. The X-ray image down below is from my good buddy, Bobby the Stub Malone. He didn't really understand what it meant when we explained that these are full cycle ratcheting tools. What that means is that once you begin the crimp process, you must finish it. There is no mechanism on there as far as a release or a safety or anything. Once you begin the crimp process, those handles must ratchet all the way into completion before they release. You'll be glad to know that Bobby has not lost any other digits after this one incident. The first thing we do is place the terminal into the correct nest and, of course, in the proper position. This next step is optional, though recommended. You may want to ratchet the tool down until it securely grasps the terminal without crushing it. Now we'll place the wire into the terminal up to the stop of the nest or at the appropriate length manually. At this point, we get to fully cycle the tool. This will complete the crimp and the handles will release. And now we can remove the terminal and inspect our crimp. Now let's watch this again as a video. Again, our first step is placing the terminal in the nest. Now we secure the terminal and insert the wire. Fully cycle the crimp tool, and now remove the terminal and inspect. Here are some examples of crimp terminals that did not make the cut. This image here shows that the insulation is in the crimp area and that the wire is into the lug area. This crimp is vertical instead of horizontal. It was not placed in the crimp tool in the proper position. Wire strands must be visible at the exit side of the terminal. And now some inspection points on an acceptable terminal. Here we see the wire insulation is held securely by the insulation crimp, and wire strands are visible on the exit side of the terminal. This is the end of Hot Tips number 6. By now, you should have an understanding of what constitutes an acceptable ring terminal crimp, and you're aware of the importance of selecting the proper materials, tools, and processes that will provide you with a reliable crimp. Be sure to contact any of our training staff if you have a question you would like to see answered in a Hot Tips video. Make sure you check YouTube, Facebook, or LinkedIn for the next exciting episode of Hot Tips. We hope this brief video gives you some idea of our capabilities in the training department. Whether you need customized training, industry certification, online training, training at our facility or yours, we can do it. STI. This is the training you deserve.